Hey, in this video I wanted to have a graphical illustration of the rendezvous hashing mechanism that is used by Project Waterpark, as shown by Brian Hunter here in this video. So here I have a little live view page, and in this live view page I can basically specify things like the number of regions across which I want to distribute the workload. I can specify how many or which zones exist in the different regions, and I can specify how many virtual machines I would like to have inside each region. So let's go for a system where we basically have 4 different regions, like the data centers that Brian used in his video. Each one having two availability zones. And inside each zone there are 4 virtual machines, and now we can basically specify how many replicas of the data we want to have. So in this case we want to have a replication factor of 4. We want to have a primary copy, which is a red one, and 4 replica, and the actor ID, or in Brian's case a patient ID, is basically the thing which goes as input into the rendezvous hashing mechanism. So if we, for example, specify patient number 1 or patient 1, you can see that the primary is in Texas zone A on virtual machine 1, which replicates in the same region to zone B virtual machine 1, but also to Florida, Tennessee, and Utah, into different availability zones and virtual machines. And when we change the patient ID to a different ID, okay, the primary here is still on the same machine as it's actually on a different machine. So here, by punching new values here into the patient ID, you can now see how by changing the patient ID, we are flipping forward and back between 2 different patients. So it's a predictable pattern on where we store the information, right? Of course, the patient ID, the name of the patient ID matters, but also the name of the data center. So if I call this Florida 2 or Utah 3, then basically the some things here can change. And of course, when I have an additional zone, then the mappings change as well. What we can also see is, so the main copy here, or the main replica, is the one in the same region, and then we fill the other regions. And if we want more replica, then we can basically scatter them into the other availability zones until each availability zone has an instance. And then of course we can increase the number of replicas even more, but of course it doesn't really make sense in that system for fault tolerance.